So we want to have a look at some graphing of polynomials. Now we've basically graphed polynomials before using calculus, but what about when we don't want to use calculus? So here we have a cubic function, so x plus 1, x minus 2, x minus 3. What do we need to consider to graph this function? We don't want to plot points, we don't want to find turning points, which means we do want to do it without calculus or drawing up some nice little tables. Well, there's a few things we can do. Firstly, let's consider critical points of crossing the x and y axis. Well, where does it cross the x-axis? When y is equal to 0, okay, what do we get? When x is equal to 0, what do we get? So we get where y is equal to the x-axis. The other two things we want to consider is, okay, what happens as it starts to approach positive infinity, okay, and negative infinity. So they're the two things as we want to consider. What happens as the x values get really large or really small. So when we're doing that situation, we can see because of the nature of this, when y is equal to 0, x would equal minus 1, x would equal 2, or x would equal 3. Any of those values would make it equal to 0. And if x is equal to 0, we get 1 times minus 2 times minus 3, which gives us a positive 6. So if we expand it out, it would be our constant of our polynomial. So as x gets really large, what happens? Well, we've got expanding it out again, the leading term would be x cubed. So if it's x cubed and approaches positive, and as x approaches positive infinity, it would approach infinity itself, because infinity cubed would give us an infinity there. As it approaches negative infinity, which way does it head? It heads towards negative infinity. So they're really what we want to consider. We're not really worried too much about the turning points at this point in time. We're just more worried about where does it cross the axis and where does it go as it gets really small or really large. So considering x minus 2, x plus 3, what would happen there? We could expand it out, but we really don't really want to do that. But it's okay to do that if you want to. Again, where does the curve cut the x-axis? Y is equal to 0, so we've got 0, 2, and minus 3. Constant in this case, well, what would happen? Well, x is equal to 0. When x is equal to 0, it makes the whole thing 0. So there is no constant, and you can see that when we did expand it out. So the y-intercept would actually be the origin there. So as x approaches infinity, positive infinity, it goes positive. When x approaches negative infinity, it would go negative. So again, our curve has that basic shape, going through minus 3, 0, and 2, and obviously cutting the x-axis at y-axis at 0. So again, you can see that with all these curves. So y is equal to 0, we get minus 4, 0, 2 as our roots, and again, it's a constant. We have no constant, so it goes through the y-axis at 0. Positive as x approaches infinity, y approaches infinity, and y approaches negative infinity as x approaches negative infinity. We can start to see that. The negative here would basically mean if we expand it out, we get a negative x cubed. So it means as x approaches negative infinity, y would approach infinity in this case. So our basic shape of our curve would look like that. Again, goes through the origin because we've got no constant, but we've got 0, 1, and 3 as our roots of our equation. Again, we can see the basic shape of the curve because we get a negative x cubed when he expanded it out. So our shape of the curve looks like that because as x approaches negative infinity, this term becomes most dominant, so approaching positive infinity. Our roots would be at 5, minus 2 and minus 5, so you can see the minus 5, 2 and 5 there, and 5 times 2 times 5 would give us our y-intercept of 50. So we're getting those critical points to graph it up. So again, this one here, we can see that when x is equal to 0, we get it going through the origin, so that's our x and y-intercept there, but also x plus 2 gives us a root at minus 2. Now, because there's a 2 there, we're going to talk about that a bit more in the next video. But what we'll call that is a double root, which basically means it's going to turn on the root there as well. So if it's an x squared there, it's going to turn on that root because it's got a stationary point at that. So we'll talk about that a little bit more in the next video. But again, we get our shape, we investigate what happens at positive infinity and negative infinity, and we see that we get our basic shape of the curve there, because that's what's going to happen as x gets larger or x gets smaller.